Okay, so in our previous video, we made a 2D array that we could select and change the values of our 2D array to show that a sound is either going to be played or a sound is not going to be played. So if it's 1 at notes played at RC, if that equals 1, then we're going to play a note. And if it equals 0, we're not going to play a note. Okay, so what we want to do is we want to be able to play those sounds now. Okay, so the thing that we want to do is, if you have not already done it, in the description below, you'll find a folder on my GitHub that is sounds, and so this is the file. This is what it looks like. This is the folder. We have C1 through 8. We have K, S, T, and so this is cymbals. We have a kick, snare, and what is T? I don't even remember. Tom. Okay, so just some standard drum sounds. Like I said before in the previous video, they do not sound great. If you want to find some better ones that you like, then you could easily substitute them in. Okay, and so what we want to do is we want to look at, I'll take out these console logs that help me identify my problem there. And what we want to look at is creating those sounds. Okay, so the first thing we want to do is, inside draw board, we are going to have to tell the user what sound they are actually clicking on. Okay, and so this is not going to be fun because it's going to be basically 18 or 16 different lines of text. Okay, and so what we're going to do is we're just going to say, and it maps to each one of those sounds that we had just saw in our sound folder. So ctx.fill style, and we're just going to make this red. ctx.font, and we're going to say that this is 20 pixels large. Okay, and now we're just going to start doing our fill text. And so this first one is ctx.fill text, and this one is going to say symbol 1, and the X is going to stay the same. So the X is always going to be 430 here because we're drawing it to the right of our grid, and the Y is going to be 45 here. Alright? In fact, the Y is going to be 45, and each one after that is going to be just 25 more than that. And so it'll make it pretty easy. We're not changing a lot here. In fact, we can just copy and paste a lot of this text. In fact, that's what I'm going to do right here. I'm just going to say, we're going to do that. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? And so, symbol 2, 3, 4, 5, 6. This is 70, 95, 120, 145, and then 170, 195, 220. Actually, this should be 220, and this should be 120. Okay, so 220. This would be 245, 270, and this is going to be 295. 320, 345, 370, 395, 420. Okay, And so here we have symbols 1 through 6. Here we don't have a symbol anymore. We're going to have, oh, so we actually have 8 symbols. So 7, 8. This is going to be a kick. Kick 1. Kick 2. This is going to be a snare. And so we have 2 of those. Snare 1. Snare 2. And these are going to be our toms. So we're going to say tom 1. Tom 2. Tom 3. And tom 4. Okay, and so just to make sure that this works properly, we're going to go ahead and run it. And we see that it is running properly. Now, this is actually being overwritten. So each frame, symbol 1, gets redrawn and redrawn, and it kind of makes it look a little bit blurry. And so one way we can change that is by deleting that area of the screen as it's being drawn. Now, we don't want to delete the whole area of the screen, because what we're doing in this collision function is we're only drawing it. So we're not going through the 2D array every single time to draw, although I guess we could. Yeah, that might be a change we make later on, okay? So right now we're not going through and drawing it green or gray every time. We're only doing it if they click on it. So one click on this screen, like right here, this happened 5 seconds ago. So if we're constantly clearing the screen, it will no longer be green, okay? But maybe we'll change that in just a second, maybe with the next video, so that we can just clear the whole screen, okay? And so now what we want to do is we know what instrument or sound is associated with each row, and so now what we want to do is we want to play the sound. So we need another function that's going to be called play sounds. And so how do we play sounds? Well, we need to define some things, because this frames per second is going to determine a few things for us, but we also want some other variables, because we just can't play sounds based on frames per second. We need the user to be able to define some things too. So we probably want something called BPM. So that would be beats per minute. Okay, so how many beats per minute are going to happen? And we probably want this to be able to be changed by the user, which we'll probably look at a little bit later, because 120 is pretty slow. It works for some music, but other music is pretty fast, like at 240 or maybe even faster. Okay, so we want that to be something that's customizable. Okay, and so here we're going to say let frames per minute equal frames per second times 60. Okay, reasonable. And then here what we're going to do is we're going to say frames per beat. Okay, so right now we have 30 frames happening a second, but we may want to, so is our beat going to happen every 30 frames? Not always, not if we're changing the BPM. So what we want to do is we want to make that a variable as well. Okay, so after how many frames do we play a sound? That's ultimately what we're getting at, because we're measuring, so these frames, are kind of like they're time measurements. Okay, so if we're thinking of every second having 30 frames, then if we've passed 15 frames, then we're at half a second. Okay, so that matters. And so what we want to do is we want to define frames per beat. Okay, so after how many frames should we play a certain sound? Okay, and so that's going to be frames per minute divided by the BPM. All right, and then we're going to say the current frame is equal to 0. Okay, so even though we're measuring in frames, we want to keep track of what frame we're on. Okay, and then the current position is going to be the position of the music note being played. Okay, so we'll look at that in just a second. The next thing we want is, if we're playing sounds, we want a function that actually plays sounds. So we're going to say function play sound, and we're going to take in a parameter here that's the source of the sound. Okay, so we're going to pass in the source, and this function is just going to play that sound for us. So we're going to say let sound equal to new audio, and then we're going to say sound dot source src is equal to the source that we pass in, and then we're going to say sound dot play. Okay, pretty simple, not much to that. And so what we're going to do down here is, in our play sounds, we're going to see if the current frame plus 1 modded by the frames per beat is equal to 0. And if it is, well, then we have reached a new beat within our beats per minute. All right, and we should play the sounds that correspond to that column. Okay, and that column is going to be our current position. All right, so what we're going to do is, we're going to say if current frame plus 1 modded by our frames per beat is equal to 0. Then we're going to say current position plus plus, and then so we are moved on to our next position, and we're going to say if current position is greater than or equal to notes played at 0 dot length. Okay, so basically what this is doing is it's going to reset our current position. All right, and so if it is greater than our length, we want the current position to go back to 0. All right, so we're going to say current position is equal to 0. All right, and here, now what we want to do is we want to play through our eye. Okay, so basically we want to play through the rows of sounds that we have at that frame. Okay, so if we look at this, this is our current position. This is our current position. And then this is our current position. We want to play through all the notes that correspond to symbol 1, symbol 2, symbol 3 at that position at any one time. Okay? And so that's what we're going to be doing here. We're going to say for let I is equal to 0, In fact, we'll just say R, so we're keeping the same naming conventions for our variables here, our loops. 16, and then we're going to say R++. I don't know why that did that. Okay, and so here, what we're going to say is if notes played at R, so at that row, and current position is equal to 1. So if that's the case, what we're going to do is we're going to say let source equal to a blank value, and we're going to say switch row. Okay, what this is going to do is it's going to say what is our R value. So if R is equal to 0, we're going to do something. If R is equal to 1, we're going to do something. Okay, so what we're going to do here is well, we're going to set the source, and so the source is not going to be fun, just like we did before. It's going to be a lot of different statements. So this is a switch, and inside a switch statement we have cases. Okay, so when case is equal to 0, which means when R is equal to 0, what we're going to do is we're going to set the source equal to whatever the source is. And for us, it's in a folder called sounds. So I do the // to get to that folder. And it's a file called c1.wave. Okay? And after that, I'm going to say break, because I don't want it to go to fall through. I'm just going to say break. Okay? And so probably just go ahead and do that. I'm going to copy that. So I'm just going to do this a little bit at a time. I don't want to put it all off the screen. So case 2, case 3, case 4, case 5, case 6, and this is so this is C1, this would be C2, symbol 3, symbol 4, symbol 5, symbol 6, symbol 7, and remember that we have 8 symbols, and so this will be case 7. We have C8. Okay, and so we're not quite done yet. We just have 8 more sounds to go. 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Great. So this is going to be case 8, case 9, case 10, case 15. Okay, and so the next thing that needs to change is just this name. So we got through our symbols, and now we have our kick, and this is going to be K2. We have our snares. And then we have our toms. Okay, so this is just going to be T1. And we have T4. Okay. And so that sets the sound up. And so after our switch statement, we're just going to play that sound. So we have a function called play sound, and we're going to pass in the source that we just set. Okay, and so that pretty much does it. Get rid of some of these lines that don't need to go there. Okay, and so that's what that looks like. So we have play sounds. Let's go ahead and put play sounds into our draw function. Okay, so just going to come down here, and so there's a few things that we might want to do. So we said that we're going to be keeping track of our frames, right? And so one thing that we definitely want to do is we want to say current frame plus plus. All right, and one thing that we could do to get rid of the fuzziness is we could do something like ctx.clear rect and do it for a limited area of our screen, since we're just drawing our stuff seconds in the past, or even it could be minutes in the past, and if we did clear rect of everything, it would just erase everything. And so we could be selective about our clear rect and say, hey, I only want to clear a small portion of the screen. And so that's what we're going to do just for now. We'll change it a little bit later. Okay, so we keep track of our frame right there, and so I'm just going to hit A, and you see that this is no longer blurry because we're doing that clear rect every time. And what I want to do is just test it. Okay, so let's see if that. Okay. That doesn't seem like it's playing them. I think I know what is wrong. So that should play there. Go ahead and do this. Let's make sure that this is a tom that's playing. So it sounds like a snare. Okay, so let's figure out exactly. So should just have a single tom, which that did work. Okay, getting a lot of extra notes, and so why exactly are we getting extra notes? Not sure. Okay. So, let's see here. Seems like we may have, or I may have, mixed some things up. So here, let's say C and R, C and R, C and R. Okay, so let's see what this looks like. Okay, so seems like that's a whole lot better. So that makes sense, that whatever row it's at, and whatever column, and then notes played is saying that column row. Okay, so it just seems like we have mixed something up. So right here, I'll go ahead and turn that off. So right here, we're saying that we have row and column, and the X definitely matches to row, because otherwise this would not work. The Y matches to column, otherwise this fill rect would not work. Okay, but when we fill in the notes played, it's doing it slightly backwards in that we're doing it by this is our row and then this is our column. And so I'm going to look into that, see if I can get some kind of rationale for that. But right now, this is what it looks like. Okay. And so let's see here. And so what we have right now is, a working sequencer. Is it pretty? No. Could there be improvements? A whole lot of improvements. But what we're going to do when we come into our next video is we're going to explore the idea of the user being able to change some of the properties, such as, for instance, beats per minute. The user should be able to change our beats per minute and make it faster for themselves. So we're going to look at that along with some other things in our next video. Sorry about the confusion there. We'll look into that as well. For me, it's not making sense right off the bat, but I'll look into that. Yeah, we'll go from there.